Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Have you ever wondered what the infinite void of space actually smells like? While we often think of the vacuum as a silent, empty expanse, astronauts returning from spacewalks have consistently reported a peculiar, lingering aroma clinging to their suits, gloves, and tools. They describe it as a mixture of seared steak, hot metal, welding fumes, and even bitter gunpowder. This isn't just a figment of their imagination. It is the olfactory signature of the cosmos, a phenomenon we call the vacuum perfume. But the story goes deeper than just a strange smell. Recent breakthroughs in neurochemistry and astrophysics suggest that the specific molecular structures found in space dust might do more than just tickle our noses. They might actually trigger a form of human synesthesia, the rare condition where senses overlap and bleed into one another. To understand this, we first have to look at the soot of the universe. The primary culprits behind the smell of space are polycyclic aromatic hydrocarbons, or PAHs. These organic molecules are found throughout the interstellar medium, formed by the death throes of giant stars and the violent collisions of cosmic dust. PAHs are essentially ring-shaped carbon structures that are incredibly stable and abundant. When an astronaut enters the airlock and the station is repressurized, these molecules, which were clinging to the fabric of the spacesuit in the vacuum, become airborne. As they interact with the oxygen inside the station, they create that distinct, pungent odor. However, PAHs aren't just simple odorants. They are geometric masterpieces of chemistry, often forming hexagonal lattices that vibrate at specific infrared frequencies. This is where the connection to synesthesia begins. Synesthesia occurs when the stimulation of one sensory pathway leads to automatic, involuntary experiences in a second sensory pathway. For example, some people see music or taste colors. The molecular geometry of space dust is unique because it mirrors the mathematical ratios often associated with light and sound waves. In the extreme environment of a spacecraft, where the brain is already struggling with microgravity and altered sensory input, the introduction of high-energy cosmic molecules like PAHs can cause a neural crossfire. Some researchers hypothesize that the high-frequency vibrations of these space-borne molecules could theoretically stimulate the olfactory bulb so intensely that the signal leaks into the visual or auditory cortex. This would mean that an astronaut doesn't just smell the burnt steak of a dying star. They might actually see it as a flash of ultraviolet light or hear it as a low-frequency hum. Consider the center of our galaxy, in the massive gas cloud known as Sagittarius B2. Astronomers have detected the presence of ethyl formate in this region, the same chemical that gives raspberries their flavor and rum its smell. If a human were to experience this concentration of cosmic chemistry, the sheer density of these complex molecules could overwhelm the traditional sensory boundaries. In a state of cosmic synesthesia, the smell of the galactic center wouldn't just be a fruity aroma. It could manifest as a kaleidoscopic display of colors or a rhythmic pulse. This happens because our brains are evolutionarily hardwired to process terrestrial chemistry. When faced with a raw, unfiltered molecular geometry of deep space, our neural architecture may resort to synesthetic mapping just to make sense of the alien data. Furthermore, the hot metal smell described by astronauts is often linked to high-energy ions and atomic oxygen. These particles are highly reactive. When they hit the moisture in the nasal passages, they produce a tiny, microscopic version of a lightning strike. This microelectrical discharge can directly stimulate the nerves, bypassing traditional chemical receptors. For an individual with even a slight predisposition toward synesthesia, these electrical shocks from space dust could trigger vivid geometric hallucinations, effectively allowing them to see the chemical composition of the vacuum. This suggests that the vacuum perfume is not just a smell, but a full-body sensory interaction with the building blocks of the universe. As we prepare for longer missions to Mars and beyond, understanding how cosmic chemistry affects human perception is vital. We are essentially stardust, trying to perceive the very dust we came from. If space dust can trigger synesthetic responses, it changes our entire understanding of how humans will psychologically adapt to the deep void. We might find that the further we travel from Earth, the more our senses blend together, turning the cold, dark vacuum into a symphony of color and sound. The universe, it seems, isn't just something we look at through a telescope. It is something we can taste, smell, and experience in ways our ancestors never could have imagined. For more incredible facts like this, don't forget to subscribe and turn on notifications.